Okay, it's like 1 minute to go, even less, I guess. Some people are still coming in. Yeah, a few seconds, and maybe I should start. Because it's almost the last talk of the conference, like pre-last talk. So I don't want to waste a lot of your time, but I still would like to tell you some new, interesting stuff, I hope. So my name is Andrey, as you probably already read on this slide that you see already for like, I don't know, 15 minutes. And who am I? I'm a developer. I'm a Java developer. I'm a Groovy developer, as I guess most of you are guys here also using some JVM language. I'm writing a lot of code, but at the same time, I'm doing a lot of DevOps kind of activities. I'm doing a lot of automation. I'm helping teams to plan, organize, and strategically define what is the architecture and what's the deployment plan, what's the release plan, and all that stuff. So I'm mixing things, but I'm writing a lot of code. I'm doing a lot of stuff like that. Also, I'm training. I'm speaking sometimes in different conferences, including this one, and I'm also organizing two things. And we're actually going to talk about at least one of them in the journey that I'm going to present you. So, and one of them is Latcraft, which is a Latvian software craft community, and Cyril, who was presenting here in the previous session, he was actually from Paris. I'm from Riga, from Latvia. That's why Latcraft. So I'm from the beautiful city on the shores of the Baltic Sea, not that far from here. Another thing I organize is Devternity. It's a conference that also happens in Riga. It's a software architecture, software craft conference. And I would really like to invite you there, but I really can't because we are sold out. Well, it happens on the 30th of November and 1st of December. So this year, unfortunately, we are already sold out. But next year, definitely go there. It's a nice conference. It's a huge conference. We have like over 700 people from all over Europe and actually all over the world coming to us. We have very good speakers, so please just check the program. But let's start talking about serverless and what it means, what it does, what kind of options are there. Is it a new thing? Is it an old thing? Yeah, let's talk about that. And the thing is that serverless as a term exists roughly from around 2012 when it appeared first in the blog posts and tweets, but serverless as a terminal, like as a way of looking at your infrastructure, at your platform, is actually slightly older. And usually, what people are like associating serverless with, and it's kind of logical because serverless in English means that no servers, no nothing. And the problem is that of course there are servers. It's like the term is kind of meaningless, and of course, we still have to use servers, have to like deploy on the cloud, or run it somewhere in our data center, maybe do it on a local machine somewhere. We still need some sort of server, some sort of hardware to run it on, obviously. And unfortunately, our industry is quite common, to introduce things that are not really understandable from their like the word that is used to describe them. For example, another one is responsive design. If you are like the person who knows English language, like responsive doesn't mean what it may mean in this particular word combination. Responsive means that it's fast to respond. And responsive design is, it's quite unlogical. I mean, it means that the technical design of some component is responding to changes in the media types, media sizes, and screen sizes, and all this stuff. It doesn't make sense from an English perspective, in an English language perspective. The same thing with serverless. It doesn't really make sense from English language perspective because it doesn't mean what it actually means. What actually serverless means, actually what you should kind of use as the way to look at this kind of technology or this kind of principle is that serverless means that you do not want to care about the service at all. So of course you still run your software, your applications, your data, you store them on some kind of hardware. Obviously you still know about the service are somewhere down in the architecture, but at the same time you don't want to care about them. It's not your responsibility, it's not your main focus. And that's what basically serverless is about. We want to use services, we want to use cloud providers, we want to use maybe or some sort of orchestrators, maybe containers, but at the same time serverless also may mean that we don't actually care about containers, we don't care about Docker, we don't care about Kubernetes, we don't care about anything that is very much oriented onto how things are actually running under the hood, because container is still just the technology. Kubernetes or any other orchestrator is still just a technology. But we as developers, we as people who are implementing some ideas that we want to deploy to production and make those ideas to bring some money, we shouldn't really care that much about what is the underlying technology, infrastructure that is being used for that. We really want to focus on the code, on the business value that it brings. And that's where I think everything's kind of going. Cloud providers, data centers with automatic software, and platform as a service, infrastructure as a service, it involves a lot of components which still are focusing on infrastructure. But at the same time, we as developers, we want to focus more on the code. Another kind of misconception that surrounds serverless, of course, we have to use servers, but at the same time, many people associate serverless with function as a service, where you run your code in some sort of container, and you don't care about what it is, but you just deploy it, you run it, and it works. But to much bigger extent, serverless is not function as a service. Or actually, it's not just function as a service. Actually, it's much more. Because if you think about it, code without any dependencies is kind of meaningless. You can't really, put your code into production, and it should use some database, should use some file storage, should use some other dependencies that it may depend upon. So function as a service is not serverless. It's only a small part of that, actually. Also, another misconception is that if you go serverless, if you go like completely automation based on APIs in the cloud or something, then it may mean that you don't need operations, you don't need sysadmins anymore. And unfortunately, there are some, lost professions that existed like back in the days. For example, switchboard operators. These women, they were like, switching on, connecting the phone lines in order for you to make a call. Of course, most likely, people in this room never seen that, including myself. But this happened, and it may seem that something like that also happens for sysadmins, because we don't need any more sysadmins who will insert disks, start the servers, configure the VMs, configure Kubernetes or anything. We go into the direction where things will be more or less automatic, and we will get our infrastructure more like a utility. We don't like now we get electricity. We don't care. But most of your teams actually don't have electrician and as part of team as one of your team members, because electricity is a utility which you can buy from like gazillion providers, and it's just somewhere there, and it always works. Something like that will happen also to infrastructure, to servers, to databases, to disks and everything. But at the same time, the profession of sysadmin will not get lost. It will actually be transformed into, and will focus more on actual business value and actual application value that you're producing. And I think even better way to define serverless is to actually rename it to serviceful. Because we're dependent on not just the function as code, we're actually dependent on database as code, messaging as code, or anything as code. And those services are usually provided as utilities by cloud providers or maybe by your own infrastructure, but I would still think it's more like cloud provider-based solutions. And the main initiative behind that is that we don't want to think too much about infrastructure. And I mean, I'm working as a DevOps consultant. I do a lot of, helping people with automation tooling. I did configure a lot of systems with a lot of different tooling. I know how to do that. And trust me, it is super boring. I don't want to focus on that. I want to focus on what actually brings value. And that's what I think, that's the fuss about serverless. Serverless is switching the focus from managing your Kubernetes cluster to actually delivering the value. And also, you can think about serverless as infrastructure as utility. Like electricity as a utility. Infrastructure will eventually become a utility as well. And it's already becoming, but it will become more and more common to get infrastructure as an API or kind of connected and you use it. And as it appears, running with serverless infrastructure in mind, with serverless architecture in mind, may end up being cheaper than running on the servers. Because servers have to be there all the time. With serverless approaches, you usually pay as you go. You pay for the services that you use. You pay for the amount of data you store. You pay for the amount of requests you make. You don't need to keep the server idle and pay for that. And actually, another way to define what serverless is, it's not just it's not just about functions as a service. It's not about running your simple code in the cloud. It's actually about a billing model, because servers have to be there all the time. You have to pay monthly for them at least. If you're running in the cloud, if you're running your own data center, you still pay for that. While they own, you pay for electricity, you pay for anyone who's observing them, you pay for monitoring tools and everything. Is all like the operational costs for servers still have to be there, and they still exist. But at the same time, with serverless, with function as a service, and also other services as a service, you actually pay for the resources you use. So serverless is really a billing model. A financial model of how you use resources, how you use utilities. The same kind of goes with electricity. You pay only for what you use, not for anything like on top of that. And you can disconnect from electrical grid. You can buy electricity from other providers because they're all connected to the grid. That's kind of the same thing. It's not happening yet, but it will definitely happen in the future because it's much more convenient billing model, and it's usually quite well understood by financial people as well. So pay as you go. But let's talk about FaaS. So I don't want to mix the terms like serverless and FaaS, and actually my kind of title of my talk doesn't make sense because serverless Java, it's only part of that, and serverless, actually I probably should have named it like Java FaaS, function as a service, because I want to focus on that part. But at the same time, function as a service means that you actually use other services that are provided by your cloud provider or data center. And quite common questions when you try to deploy some code into a function running in the cloud usually, or on your infrastructure. How do I configure a database inside my function? Or how do I add some storage into my function? Or how do I install some additional component running inside my function? And the answer to those questions usually that you don't. You don't do that. Because functions are supposed to be small pieces of code that like a microservice that are only focusing on a single functionality, or single integration, or single API. And the features that you get with that, with function as a service, you get logging and auditing on top of that. You get some rate limiting automatically. You get some auto scaling for that, and you get security controls, and you get maybe multiple version deployments easily. I mean, it's all built in. It's all part of the function as a service offerings usually. Simplified deployment, I'm not sure about that, but in most of the cases you get also simplified deployment. But what you have to buy additionally in order to kind of make this function as a service useful, you have to integrate it with database, so you kind of like buy a service from your cloud provider to get a database. You have to buy storage, which could be like S3 if you're using Amazon, or maybe some other cloud provider. Messaging, and actually anything that is included into the cloud offering, you have to buy it, because otherwise it doesn't make sense to use function as a service by itself. And there's another term that kind of exists at the moment. Actually, well, there are many. If you take like English alphabet, you can actually find a term for anything as a service in that. And well, the one that comes with B is backend as a service. And as you probably know, most of front-end applications now are kind of static apps that you can deploy to a CDN and then use it from there. And they talk to APIs. And APIs have to be provided by someone. And if I needed to implement, some sort of functionality, some sort of API, or some sort of backend, and with some REST interface or GraphQL interface, back in 2008, I would probably use some sort of app server like Jade or Tomcat, or maybe if I were in the enterprise, I would probably use WebLogic or WebSphere maybe. By the way, is anybody still using WebLogic? A couple of guys or three? So some guys. Well, I'm sorry. Yeah, well, I still have clients who are using WebLogic as well. I'm trying to convince them to go away from that because it's a huge waste of time. And some of the applications were actually created in 2008. So, I mean, if I were in 2008, would still have a server with a web app with my API. I still have a server with a database, and I probably will have some disks or NAS drives or something attached to my servers we'll share some file system resources. So at least
2 servers, but at most maybe 3 or 4 or 5, and it's going to be quite expensive, you know, to support them and scale them. And at the same time, if my application was small, my servers would still be there and run that code, even though the code is not used. So it will be underutilized. If it was like 2015, maybe, because, you know, it was like the rise of Docker and rise of containers in general, probably I would do the same thing. I would put Tomcat and Jetty into a container. Maybe I will deploy it to something like Heroku or Google Apps Engine. Still, the database will be on a server. I probably will, I don't know, put it into a container, put a data volume somewhere else. Maybe I will use a cloud provider because, you know, cloud providers at that point were much more mature than they were like in 2008. And for storage, I would probably use a volume on a server drive. And again, still I have to manage some servers, maybe with some shift to the cloud. But at the same time, I still manage some servers. If it was like now, I would probably not go that way. I actually would try to go away from servers because, you know, in my career, and it's like quite many years, around 20 years, I have configured a lot of servers. I have automated maintenance of a lot of servers. I used all the tools like Ansible, Docker, Puppet, Chef, Kubernetes. I used all of them, and I don't want to go back. I mean, it's fine that we have some automation around that, but at the same time, I don't want to struggle with the problems of, you know, security patching, servers, scaling up the servers, and I mean, some of the problems can be solved with, you know, Kubernetes. Some of the problems can be solved with all the scaling in Amazon. But at the same time, I really don't want to focus on these problems anymore because I solved them many times. And I really want to focus more on the business domain. And in 2018, I would probably go to function as a service surrounded by other services in the cloud because it allows me to scale quickly. It allows me to not to pay too much for idle servers, especially if it's a greenfield project and doesn't have any customers yet. My experimentation capabilities actually increased because I can create a production-ready functionality without paying too much for infrastructure up front. Even without planning for infrastructure at all, I just use the service, and that's actually quite a good thing to be. Because I don't want to, you know, do babysitting with my infrastructure. I don't want to accumulate technical debt because whatever infrastructure you have, despite of like maybe that you use Kubernetes or you maybe use containers, you still accumulate a lot of technical debt with your infrastructure because you have to support it, you have to update it, you have to scale it, and I mean it's all doable. But at the same time, there's not so much time to invest into solving problems that you already solved at some point. And also, I would like to minimize my operations effort. I don't want to, you know, spend time on doing all those things and paying technical debt. And I want to minimize the cost of my unused resource. I only want to pay for things that I use, like with electricity. If I'm not at home for a month, my electricity bill will be very small. If I'm using my home, if I'm living there, my electricity bill will be larger, obviously. And I want to have the same effect with infrastructure. When I use it, or when my customers are using that, then I'm paying for that. When I'm not using, well, it should be close to zero. And talking about function as a service, I mean, it's a nice concept, and I probably already told a lot of good things about that. But of course, you have to know the pains, or actually the limits of function as a service in general, because usually when you're running code inside a function, the memory size is limited. The archive size, how much code you can put into that function, is also limited. But at the same time, it's big enough for even big, complex monolithic applications. CPU count is limited. Also, the major problem of function as a service providers is that it has some cold start. So when your functions are not used, they are kind of deregistered, removed from the active usage. And when someone is accessing a function, then function has to start. And then it could be that the cold start is relatively long period of time. It takes takes some time. It could be that sometimes, and so actually with my experience, some providers, the deployment time of a new function may be slightly longer than you expect. In some cases, it's very fast, like a few seconds or less than a minute. In some cases, with some of the providers that I used, it could be like 10 minutes to deploy a function, like a single function, and that's maybe is a bit too much for a piece of code that is like 100 lines long. Also, another thing that people are talking a lot about, functions as a service and serverless in general, is that you are actually locked into a specific provider. It's true, but I think it's getting better because we kind of getting right abstractions and built into the libraries, built into the tooling, allowing us to transfer at least some of the code into other providers. But at the same time, this vendor lock-in, I think it's not that much problem because you get this nice billing model where you pay as you go. You only pay for things that you use, not for the things that you kind of bought up front and they're staying idle for you to use them. So vendor lock-in to me is not a huge issue, and especially if you implement like applications that are relatively small and they focus on similar functions, it's actually easier to do a gradual transfer from one provider to another, or maybe also do a gradual transfer from your huge monolithic application running in your data center into small functions running in the cloud, and it doesn't need to do big bang movement. You can actually do it like in small chunks. So it actually gives a lot of flexibility and a lot of simplicity. Also, kind of some of the FaaS offerings out there, they only work with only some languages. So of course, some of the FaaS providers support Java. Most of them support Node.js. Most of them support Python. Some of them support Go. So if you're not like a Java programmer, or if you are a Java programmer, then you probably have slightly limited options. If you are a Python programmer or Node.js developer, then you usually have more options where you can deploy your function as a code. And at the moment, these big clouds, well, maybe Zeit is not the biggest one, but to Google Cloud, Azure, and IBM, and AWS, they all offer some sort of function as a service. Also, not that obvious, but some of the specialized cloud providers like Cloudflare, which is DNS provider, they offer so-called web workers, where you can run a piece of the code at the edge, and where basically your client's executing that code, but they kind of make it close to the client as much as they can. So it's kind of a serverless solution. It's a functions as a service solution, but very specialized for the DNS and kind of content delivery kind of use cases. Also, Firebase functions. If you have ever written Android application, you may have heard about like backend as a service in form of Firebase, which also supports functions built on top of the events happening in the Firebase database. Also, there's some other ones like Webtask.io, Zapier.com, Glitch.com. They also offer maybe not as code-oriented as the other solutions, but at the same time, it's also like function as a service. It's also a serverless solution allowing you to join different APIs, different integrations without actually paying too much for that. So it's also, to me, it's also serverless. And recently there was like a survey done by Snook.io. Maybe you've seen that. It was appearing on Twitter. Different people were talking about that. And it seems like Java people it's a survey about Java developers, among Java developers. And you see that some Java developers already, like 9% of Java developers already are jumping into the FaaS type of deployments. By the way, anyone here is actually deploying their code to function as a service solutions? 1, 2, 3. Yeah, well, not 9%, but roughly maybe 2%. Still, well, something is happening in that area. And speaking about Java and function as a service in the cloud, Amazon started kind of this function as a service ride or marathon. They published the first implementation of Amazon Lambda in 2014, and they started to support Java since 2015. IBM support Java since 2017. Oracle Cloud Functions also have something, but it's Oracle documentation is not really good. That's my opinion. It was really hard to find information about how to do it, but they have to support. I mean, they own Java. Azure Functions does support Java, but only in preview mode, which I hope will be kind of available next year as like general availability. Google Cloud Functions unfortunately doesn't support Java, but at the same time they had Google Apps Engine, which was there since 2009, I believe, or around that time. It is actually platform as a service. Actually, I would say it's also kind of a serverless solution, even though nobody used the word serverless at that point. So serverless principles, serverless architectures, they started to emerge much earlier than the term was introduced. And now, yes, as I mentioned, serverless is actually meaning serviceful. You combine different types of services from cloud providers together in order to work in concert and minimize costs and minimize simplified delivery. Now, yes, also another one side is providing that. Also, if you want to run function as a service on your infrastructure or on another kind of on infrastructure as a service, you can use some of the solutions like Kubeless, Knative, FN Project, OpenFaaS, Apache OpenWhisk. But to me, I think it's you still have to manage servers in order to run these kind of things on top of that. So I would say it's not really serverless. It still requires some extra effort to support the infrastructure, and that's not what I would call serverless. So, okay, I give you the background, I give you the landscape at the moment, and let me now start to tell you about my journey into this world and into the world of serverless. And the journey started with an attempt to automate community management back in Riga, Latcraft, and we had to integrate a lot of things. We have to integrate, especially when we had to publish the event, we had to integrate a lot of services like Eventbrite, Facebook, Linear. Well, it doesn't exist anymore, but it existed at that point. So around 2016, we started to write some scripts that simplified these things for us. And of course, since I was the main author of all the scripts, I knew how to run them, but people in the team, they didn't really know. Well, they knew how to know that, but it always was like a entering barrier in order to get those scripts, configure everything on the local machine, and then start them. So it was a bit problematic. And well, I knew that like Lambda functions already existed for a while, and I knew Amazon quite well. So I decided, why not to put all my scripts, all my actually Groovy scripts at that point, why not to put them into Lambda functions and build some APIs around them? Of course, I could probably rent a server and do it like in a server type of way. But I decided to try a new thing. I decided to try a new technology, and at the same time, I really wanted to minimize the cost because, well, community is community. It's free for attending, and it's really don't have many sponsors. We really try to run it ourselves, so we don't have much money, and having to spend some money on a server that will only be used for like a few days in a month was kind of an overkill for us. So I decided to play with technology and spend some time on finding a solution that will not cost anything from infrastructure point of view. Of course, it costs me a lot from like my development time, but at the same time, infrastructure costs almost nothing. So I had a Groovy script at that point, and I decided let's just try to deploy it. Well, Groovy script is a Groovy script. It's just a Java program, and I had to repackage it. I had to package it as a function. It was not that hard. I implemented the interface. I implemented imported all the libraries that needed. Okay, deployed. So how do I call it after that? And in case of Lambda functions in Amazon, you can't really call it without using Amazon API, Amazon SDK. At the same time, if you're doing it, if you're not using interface like the web console interface from Amazon, you probably miss some steps because I wanted to be like fully implemented fully as code, and I didn't go through UI, and so I had some problems with enabling the logs correctly, enabling the correct security policy for that functionality. Eventually, I went through, but it took me some time to get there. So the onboarding to using Lambda functions at that point, and like in 2016, was not super friendly in my experience. Then I decided I still need to call that kind of API of some sort. So I needed API gateway from Amazon, another service from Amazon. So API as a service connected to my Lambda function as a service. Then I can kind of call it from anywhere. Not force anyone to install Amazon SDK to call my Lambda function. Well, I needed to generate some images to like publish on different social networks, and unfortunately, API gateway required a lot of extra configuration in order to publish or return binary files through API gateway. So, I mean, at that point, I needed to consume another service. I needed to consume S3 service to store my files there and get that get that link back, because otherwise it would require a lot of config and a lot of like extra work. So after a while, I had the project working, like generating images, publishing stuff on Eventbrite and other stuff, and other sources. And why not integrate it with Slack? The problem is that, well, my Lambda for generating an image was actually relatively long. It was using some SVG templates to convert them using Apache Batik into PNG. It actually took quite a lot of time. Well, not a lot, maybe a minute, maybe a minute and a half. But it was not really integratable with Slack, because Slack has a limit on 3 seconds for a command to return something, and obviously it was not really usable. So the initial experience with Lambda functions and functions as a service and all the infrastructure I needed for that, like S3 API gateway, also KMS for security, and also some policies that I needed to set up in order for all this thing to work, it was not simple at all. So experience in 2016 was quite frustrating. So the question was, for me at least, why did I start that? Why did I actually wanted to use the more complex stuff when I can just package it all together and deploy it to a server? That was kind of obvious question, and I still wanted to go through and to see how I can benefit from that. I try to continue my journey and try to implement some more stuff on top of that. Of course, we have this, problems with timeouts, because Lambda function in 2016 the maximum timeout was 300 seconds. In 2019 they increased it to 900 seconds. So that's the maximum amount of time your function can execute. And sometimes it's not enough, especially when you're generating very many images for your event. It could be not enough. Of course, you have to split it in some way. So the first solution was to split the code into more fine-grained ways to execute and generate elements of that. But then we hit another limit. So API gateway has a limit of 30 seconds. So when you request something from API gateway, you get 30-second timeout. When and then again, if your Slack is calling your API gateway, you still have to be under 3 seconds in order to get some meaningful reply. And the problem with cold starts is that most of you know that Java is JVM is a beast that is supposed to work for a long time, and it takes some time for that. For JVM to initialize, to warm up JIT caches, to warm up, to load all the classes. So, of course, the platform that, in order to run any functions, you still need to have some delay in order to get all these things initialized. Actually, it was usually around those like 2-3 seconds. It was a cold start. So within those 2-3 seconds, actually, my JVM was not doing anything except trying to initialize. That's what is like a bad experience in that. So the first thing we did in order to kind of isolate the different commands and different routing stuff, we decided to do a routing function that was accepting different commands and was calling another function that may be called, that may take more time to execute. So image generation was a huge, it was taking a huge time, like 1 minute, 2 minutes, sometimes 3 minutes. So we couldn't directly integrate into Slack. So that's why we implemented a routing function that was calling another Lambda and then sending back result into a Slack channel, so we can at least observe it asynchronously. So asynchronous communication in Lambda functions is quite important, because especially if you integrate it with low latency, with systems that have low latency requirements, then you have to be creative around that. And routing function and callback channel was the way we did that. Another thing that when you call a Lambda for the first time, of course it's going to be a cold start. It will take at least 3 seconds, or usually more, to initialize the function. When you call it second time, it's actually fast, because JVM is already running. Because AWS and other functional service providers, they keep the JVM running and responding to any incoming events. One solution that we used for to keep our Lambda running and warm, Amazon introduced so-called cron events, where you can schedule function call every 5 minutes, and then the Lambda is kept warm. So it's not removed from primary. It's not deregistered by Amazon. And when you call it, you get more or less quick reply. The only problem with that was that when you have 2 simultaneous requests coming into a Lambda function, then one of them will get into the warm function. Another one will actually force Amazon or other cloud provider to create a new instance of the function because it needs to scale. So still, the cold start is still a problem, and we still have this. We're hitting this warm mapping issue with the JVM because we still need to spend some time to initialize JIT and code caches. So eventually, the whole this setup with event publishing and image generation and social network integrations turned out to be like that. So we had some functions in here and one API, and we're all integrating together within the single channel. It worked fine. It worked fine, and the good thing is that we didn't really pay much for that. We paid a bit for S3 storage. We paid a bit for KMS, like for encrypting secrets, and that's pretty much it. So supporting a low volume business like that for us was kind of a good thing because we didn't pay anything for like maybe a couple of dollars a month. So it was very, very cheap. And unfortunately, the initial experience with managing infrastructure for our functions was not that. It's not just the code. Actually, it's all the resources that we consume as a user of a function as a service. So we needed to use Terraform in order to describe all these resources, like S3 buckets, KMS keys, different GitHub projects, DNS integrations. We had to describe it somehow, and we had to. This code was living together with the code that was implementing our functions. In order to deploy functions, we decided to use Serverless framework, which it has very good, well, very bad name because it kind of confuses the framework with the term serverless. But the framework itself actually is quite good because it's kind of managing the actual deployment and creation of the resources that are surrounding the function. And that actually is not a single resource. You have to define the policies, you have to define log integrations, you have to define deployment targets, and all of that serverless is taken care of, which is very, very handy. There are some alternatives to serverless.com framework, like Cloud.js, Apex, SHAP, Amplify, and most likely someone is writing another one right now. There are many ways to deploy function as a service to a cloud provider, and I'm pretty sure the more things will come in that area. People are creating stuff. It's very like young thing. Okay, let me show you some code now, like a very simple function and how I did that in Java. So I have this one. Let me see if I can. So it's a Gradle project, and it has just a single handler, and yeah, this is the code. The good thing about the code is it's small. It's just one function, just one class. The bad thing about the code is actually that it's actually using some of the functionality from Amazon. Maybe it's not visible here, but it depends on some predefined interface. And the context object, as you see here, that's the functionality coming from Amazon Lambda. So I'm kind of creating an implicit coupling here with my code and code from Amazon APIs, which is maybe not bad, but at the same time, it makes the testing of this code quite hard. Well, not hard, but in my initial implementations, I had to mock all these context classes and do some of my own implementations in order to have an ability to test my code somehow. Let me show you maybe how to run that code. So I have it. Do you see that? So this is the project. It doesn't have much code. It just returns the function. So, well, I already built that today. So it's just Gradle clone build, normal Java project. It builds a jar file. And then I'm using a serverless framework in order to deploy that code into Amazon. And as you see here, I'm using like Java 8, and artifact is like that. It's built by Gradle. And then I'm just specifying which handler function to call when the code is coming in, when the request is coming in. And there's a bit of magic here to make it work with API gateway. And serverless framework manages the function, the API gateway, and all the permissions for me. Otherwise, I had to go and configure that myself with Terraform or with CloudFormation or something. So I'll just show you that it's actually deployable. Let's see if my if internet works well. You see the size of the archive actually is quite small. It's like almost like 2 megabytes. So it's just the code and maybe some descriptors. And usually it's relatively fast. And you see it's creating CloudFormation CloudFormation stack to deploy all the resources we need to run this function. Let's see, it should be fast. So yeah, it's deployed. It's deployed, I get the URL, and now actually I can go and call that function. And I could probably do just curl, but what I would like to do, I would like to actually call a different one. I will call the tool called Artillery, which is like a simple load testing tool. And I will show you that, because the function is just deployed, it's called. It's not it's not warmed up. And if I execute that, now what I do at the moment, I'm running like 30 requests with the rate 5 requests per second. So 5 requests are coming immediately, simultaneously, and then we get this kind of responses. So the maximum response is like 2.5 seconds, which is probably too much for a function like that. But at the same time, the median response, like the average response, is quite small. It's like 400 milliseconds. So for web applications or for backend APIs, usually it's quite okay. If you really need like a low latency requirement, then you have to be sure that your Lambda is warm, or you have to somehow reduce this time of loading the Lambda. So now you see my maximum time is 2.5 seconds, but if I run it again, my Lambda is already warm. So most likely it will actually be some better numbers. So now the maximum time is 1 second. So it's getting faster. Because JVMs that are running my Lambda instances, most likely several JVMs, they're already initialized. And they actually respond much faster now. So we took 1 second away from the maximum, and the median is becoming slightly faster as well. We had to, you see the maximum was like 3 seconds. So most likely somewhere in my load test, it actually required a new Lambda start, so it actually did a cold start at some point. And the funny thing is that I get much better numbers if I do the same kind of stupid function with Python or Node.js. Because they don't have this, initialization time that JVM has, and that's why, using Java for like low latency requirement, where the low latency is required, it's not really feasible. I can also show you maybe another one, the framework that I discovered a few months ago, and actually I like it a lot. It is a framework that kind of similar to Spring and Grails, but at the same time it offers very minimal deployments for specifically function code. And what I like about that is that, I'll make you a demo from that, like I'll show you the similar function that I implemented in plain Java, but I will implement with the help of Micronaut framework. So still have the same or kind of similar code for running my stupid function. So returning example message with some content, but at this time it's not kind of coupled with any of Amazon APIs, which is great because I can actually test it without requirement of using any Amazon APIs. I can easily test it. I can mock it, and also the good thing about Micronaut that you can package it as a function for deployment as an Amazon Lambda function, and you can also package it as a client library, like a command line utility, and use it from a command line. And you can also package it as a web app and run it as a web app, which is really great if you want to migrate your functional code to different targets, like cloud, own server, maybe a command line utility, and this framework brings a lot of flexibility in that regard. So your function becomes really a simple code that is testable and runnable. I can also show you an example in Groovy. And in case of, is it Groovy? No, it's not Groovy. This should be Groovy. Still Java. Doesn't want to switch to Groovy. What? Okay, I'll show you that in the different screen then. So basically, the code for Groovy it's even smaller. So I really like that because I can basically just focus on my core functionality, on business functionality, and I don't care about the noise about surrounding my classes in order to implement some testability and anything, because it's part of the framework, part of the things that are done behind the scenes by the deployment tool. And I can also deploy these kind of things to the cloud, and I do the same thing. So it's a normal Gradle project, so I've already built that, and I can do serverless deploy, and it has very similar descriptor, serverless.yaml, and I will get that service deployed into the cloud quite soon. And in this case, you see the size of the binary of the zip distribution is like almost 10 megabytes. Of course, it's bigger than the plain Java, but at the same time, we get a lot of functionality that is backed into that. And another good feature of Micronaut that actually doesn't use reflection. It generates some of the code for behind the scenes, which makes the code actually execute much faster than if you would use like Spring Boot or something like that to run your Lambda function. So it's quite a good framework, quite a good framework. It's still a release candidate, but I think they will reach version 1 quite soon, and it's quite handy in terms of organizing your code around Lambda functions. Okay, yeah, let it deploy. And I have like 4 minutes left, which is too little. I need more. But it's kind of the same thing. I will run, was it Groovy? It was Java. And in this case, I think the time will actually be bigger than with the original case, because the starting time for you see now we have actually 6 seconds. Because again, the JVM needs some time to warm up, and now we're loading more classes into JVM, which of course puts a lot of pressure on JIT, puts a lot of pressure on class loading functionality, and of course when we do a cold start, we have bigger times, and the more code we put into our zip that we deploy to Lambda, the bigger is the cold start time. But if I run it again, like on already warmed up functionality, then it should be slightly faster because things are already initialized. Okay. So take a look at Micronaut, take a look at Lambda functions. Also, I would recommend using some monitoring tool together with your Lambda functions, because at least in Amazon, the CloudWatch interface is good, but it's not super good. And I really like, this interface, which actually shows much more information about how many executions there have been and how many functions have been called, and I can click around. So I really like dashboard to actually navigate my functions. Also, another thing, it shows how much it cost me, even though this number, it should be even lower because I have like some free layer, free tier in my account. So I like that one. I wanted you also to try attack my function at the moment, just to warm up a bit. If you go to this link, bit.ly GeeCON attack, you should actually call the function that I'm calling as well. And we can kind of try to observe it during the break, how many requests we get. So just use your mobile device, quick refresh button several times just to see how many requests we get and how many cold starts we get and how fast is the response. No? So that function is actually this one. So you should get this, and it's Micronaut Groovy, and it's actually should respond quite fast. And if I do live update now, let's say we take the last 5 minutes. Do you send anything or? Okay. Let me do it this way. Yeah, we see some stuff. I'll take last 5 minutes again. Okay. Doesn't seem that data is coming in for some reason. I'll take last 15 minutes. Yeah, it seems like we were getting like 200 invocations now, around that time. And yes, all demo guides are not with me today. It doesn't show me all I wanted to show you, but hopefully it will show up after the break. And well, to finalize that, I need maybe another 4 or 5 minutes. Excuse me for that. Another project that I actually did with like in a serverless style is called DevTube. It's an accumulation of developer videos from various channels, and it's a searchable database. So we tried to use Java in the beginning, but given all our experience with cold starts and the frustration of using Amazon, we actually tried to do it differently. But at the same time, we have like a huge success story with that. At some point, some of our friends published the link to DevTube on Hacker News, even though we didn't want that at that time because we were not ready. Well, we thought we're not ready, but because we based ourselves on serverless architecture, serverless functions scaled quite well. So actually, we didn't care at all about infrastructure. And at our peak time, we had like almost 40,000 users during a single day hitting our server, hitting our infrastructure from Amazon, from Google Cloud at that point. And it actually worked quite well. And we didn't have any alerts or anything. It just worked. So this is a huge benefit. Like if you have like accidental success with your deployments, with your code, then serverless allows you to stay sane. And actually, we didn't pay much for that. Like our busiest month probably paid like maybe $20 for all the infrastructure, and we didn't care about scaling and anything. It was automatic. So at that point, we didn't use Java for that particular case, and we used Node.js because we actually deployed it to to Google Cloud Platform, and because Node.js doesn't have this initialization fee that you pay for, initializing JIT and class loading. Cold start actually became the problem of the coder. Anything we did in the code was our problem, and we could control that. With Java, we cannot really control that because we have to still pay this price, and we use Google Cloud Platform for that. But there is still things that you can do in Java. Unfortunately, because most of the platforms that are supporting Java at the moment, they run on Java 8. But in Java 9, or actually in Java 10. The feature was available in Oracle JDK and since Java 8, but in OpenJDK, which is the platform that is being used by most of the cloud providers, they didn't introduce that. But in Java 10 they did. So it became part of Java 10 functionality. Application class data sharing, something that you can preload some of the JDK classes when the application starts, so you make it faster to load. So you reduce the loading time, and this is what cloud providers actually should implement eventually. They didn't yet, but this will definitely help to minimize this startup time, cold start time. Also, ahead of time compilation was implemented. Part of that was implemented in Java 9, which again is not available in the cloud providers because they still standardized on Java 8. Something that, if it gets there, would actually benefit as well. Also, maybe some of you heard about GraalVM. Actually, it's quite cool. I think every Java conference has like GraalVM talk at the moment. And there were some, experiments with GraalVM where you can actually create a native image, like a native executable from your Java code, and run that code on your infrastructure. Or you can actually, there was an experiment. Mustafa did an experiment. He deployed a native Java executable into Amazon Lambda function written in Golang, and it actually worked. And actually, the startup time, the cold start time, was actually much smaller compared to a plain JVM running in Amazon. And he got these numbers. So max duration time, as you see on pure Java function, is like 3 seconds. But at the same time, combination with GraalVM and Go reduce the time like 3 times, which is great. Conclusion from my side, definitely Java is useful and fast, especially if you have no latency requirements. Tools, you still need tools, and they're definitely getting better, like Terraform, Serverless, and also Amazon also introduced a testing tool for Lambda functions called Sum. Different libraries like Micronaut help you, manage the code, manage the things, and implement better testing. So you really focus on your functionality, not like infrastructure. Hopefully, this year, next year, cloud providers will implement more post-Java 8 features into managing their runtimes. And this will make Java even better in that space. So the journey continues, and thank you very much.